Kaya and welcome Bob Walk students. We've got our lovely video for methods starting on sequences and CAS or our class pad and then moving on to arithmetic sequences. Starting off with just some examples, so using a calculator with explicitly defined sequences and then moving on to using a calculator with recursively defined sequences. On my little emulator here we can see the sequence button just from the main menu on your class pad. It brings us to two tabs, one's explicit and one is recursive. Our first question was explicit, so we'll stay here. We need to use a calculator to generate the first 10 terms of the sequence of numbers defined by the rule Tn equals 3 plus 4n. Fortunately, I can just type in that, 3 plus 4n. If you're struggling with your own device, you don't even have to use the keyboard for the n. You can use this lovely button up here. It does the same thing. We need to check that, so we derive it and then click our button at the top to get a list. It only goes to 5. I need to change my variables, click back on the box. Start at 1, end at 10. That was that button up here with the X and Y. And then I re-click the button to regenerate. We've got all of them from our starting point at 7 all the way down to 43. Those are our answers there. I'm going to copy and paste this. For mine, you would of course write them all out. Next one, we're looking at recursively defined. So we'll switch to the recursive tab. We need to put in a slightly different terms in this one. Our calculator only does the next term rather than defining the current term using past terms. It's determining the next term based off the current term. So an plus 1. If you have it set to a different one, like a naught, it expects you to have the naught term or the null term rather than the first term. We switch to the first term. So instead of writing Tn equals Tn minus 1 plus 3, I'll be writing An plus 1 is equal to An. I get our An up the top here. And then add 3. Exactly the same function. Because we define A at 1, which is our T at 1, as 1. Click that. Click our button to generate the list. And again, we're starting at 1 and going up by 3 each time, all the way to 28. Next, we are plotting the graph of the sequence against n. We can click the graph button at the top here. It's quite clearly done it already because I've had it in advance. But if we had started with our default values, it would have looked a bit different. We need to change those axes. We're going from 1 to 10, so we'll go from 0 to 10. Our minimum is 1. I'm going to start below the x-axis just so you get a little bit of the axis in there. Up to 30. Okay. And then we can see the axis down the bottom and our 2. You can also see that is our linear graph as it's going up by a constant each time. Similar to 3x minus 2-ish. Now we're moving on to arithmetic sequences. A sequence in which each successive term is found by adding a fixed amount to the previous term is called an arithmetic sequence. That is, an arithmetic sequence has a recurrence relationship of the form t to the n equals t to the n minus 1 plus d, where d is a constant. For example, 2, 5, 8, 11, 14, and 17 is an arithmetic sequence going up by 3 each time. The nth term of an arithmetic sequence is given by t to the n equals a plus brackets n minus 1, close brackets, d, where a is the first term and d is the common difference between successive terms. That is, d equals t to the k minus t to the k minus 1 for all k greater than 1. In an arithmetic sequence, the nth term Tn is a linear function of n. We'll see that in some of our questions for tomorrow. So our examples: find the nth term of the arithmetic sequence -4, -1, 2, and 5. So we've got all the values we need. So again, moving back to our little equation. Tn equals a plus n minus 1 d. We see in our first one, a is going to be -4. N is our term, so 10 minus 1. And d is how much it's going up each time. -4 to -1 to 2 to 5. It's going up by 3. So d is 3. We're looking for t to the 10. You can chuck it in your calculator if you're in the non-calculator section. Less luck. I'm going to have to do 10 minus 1 is 9 times 3, 27. 27 minus 4 is 23. And just adding on the side, a equals -4, first term. D equals 3, common difference. N equals 10. Alright, our next example. If 41 is the nth term in the arithmetic sequence, -4, -1, 2, 5, which is the same as the last one, find the value of n. So we can chuck in all we know. We know that the t to the n is 41. We know it'll be of the form a, which is -4, our first term, plus n minus 1, times d, which is still 3 from before. We can expand those brackets, -4 plus 3n minus 3. We can take the integers from the right-hand side over to the left. So 41 plus 4 is 45, plus 3 is 48. It's equal to 3n. Divide by 3 to both sides. N is equal to 16. So the value is 16. Our last example is a bit more elaborate. A national park has a series of huts along one of its mountain trails. The first hut is 5 kilometers from the start of the trail. The second is 8 kilometers from the start. The third is 11, and so on. Our two questions are: how far from the start of the trail is the 6th hut? How far is it from the 6th hut to the 12th hut? So for part A, we need to find what T6 is. For part B, we need to find the difference between T6 and T12. So A, T6. It would be useful if we actually define Tn first. So we know our first hut's at 5, so that's our first point. We know we are adding 3 each time to go from 5 to 8 to 11. So that's our general formula, and then we can specify for 6. It's 5 plus 6 minus 1 times 3. 6 minus 1 is 5, 5 times 3 is 15, plus 5 is 20. So our 6th hut is 20 kilometers from the start. Of the trail. Part B. Still using the same formula, we can find T12. 5 plus 12 minus 1 times 3. 12 minus 1 is 11, times 3 is 33, plus 5 is 38. We then want the difference between those, T12 minus T6, 38 minus 20. It's 18. So distance from the 12th hut to the 6th is 18 kilometers. Hope you followed that. Feel free to have another rewatch to see everything in action. Otherwise, I'll see you, or your teacher will see you tomorrow. Bye.